When I was a student at university, we were told that the advent of cheap and powerful devices would set programming back 25 years, or words to that effect. And I think that was attributed to Dijkstra. And I think this task, which I came across in a computing teachers forum, is a good illustration of that idea. So the task is this. So we know that a number of cups and coffee were sold, no more than 100 of each. Tea is £1.20, coffee is £1.90. The total came to £285, but we don't know how many of each were sold. And we can't do it algebraically because we're only given one fact, and we've got two variables, the number of cups of tea, the number of cups of coffee. So if we were given a second fact, we could use simultaneous equations or something. But a brute force algorithm is probably a good way to go with this. So we're going to try some combinations and see if that arrives at the right value. So everybody in the teachers forum was suggesting nested loops. So you could do something like this. You could say for let's say called T for T in range. Now it doesn't say there can't be 0. So and there's no more than 100, but remember Python stops one short. So we're going to count up the number of cups of tea, and then we're going to count up the number of cups of coffee. So we're using nested loops to generate the combinations. So C in range, so the same, could be up to 100 cups. And then what we're going to do, well, one thing we need to check is when we're solving a problem of this type, whether we know that there's only one solution, or whether we know that there could be more than one solution. So you need to be a little bit wary of using a while, for example, and stopping when you found an answer, because there might be more than one answer. Now, in this case, I know that there isn't because I've done it before, but we're not going to use while. We're going to use for and generate all the combinations. So what I'm going to do is if so T was £1.20, wasn't it? So if T times £1.20 plus coffee times £1.90 is equal to 285, then what am I going to do? So I'll just print the numbers. So I'll print T and C. Okay, so if I run this, now bearing in mind this is Baston, this is an online IDE that runs in the browser, let's see how long that takes. So pretty much instantaneously, and if you do it in idle, it'll be even quicker if such a thing is possible, and there's not a perceptible delay there. But if we look at this, a typical GCSE question on nested loops might run along the lines of, how many times is line 3 repeated? So we're repeating the top line, well, it's actually 101 times, isn't it? And the second line also repeats 101 times. So that should be 101 there. And so that's roughly 10,000 repetitions, isn't it? And that's doing that pretty quickly. And so I was saying, well, 10,000 repetitions for that seems a bit excessive. And that's probably because I learnt to program in the 1980s, when computers were obviously much slower. So what I've done is I've got here the BBC Model B emulator, so we can see how long pretty much that same program would take running it on the sort of program that I used when I was learning to program. So I've preloaded my disk and I've pre-saved the programs. So if I say load, so this is the nested loop solution. If you're not familiar with BBC Basic, it is quite similar to OCR's exam reference language if you're an OCR GCSE school. So loops work in the same way. For t equals 0 to 100 means make the value of t be all the values from 0 to 100. Similarly with C, and then we use next to end things, which might be unfamiliar if you only use Python, but most programming languages you need something to end a loop, a bracket or a next in this case. Notice that there's no indentation, and actually the line numbers are part of the program, but that's not really relevant to this particular task. So what I'm going to do is I'm going to run this, and let's see how long it takes. It's pretty much the same program. The only difference I've made, and we'll talk about this in a minute, is I'm using integers rather than floats for the prices, etc. Doesn't make any difference really with this particular case in terms of the calculation, but you'll see why in a minute. So I'm working in kind of 10 pence units. So I've multiplied all the numbers by 10 so I can use a whole number. And that's quite often a good idea when you're dealing with money. So if I type run and run this, let's see how long it takes. This is running at kind of real-time speed. In fact, it says in the title bar it's running at 0.98 times the speed of the real thing. So let's that go. Remember that the Python version in the browser was pretty much instantaneous. So fast, in fact, I didn't bother to time it. But as you can see, this is taking considerably longer. Why does it matter if a program takes longer to run? Well, obviously you can be running multiple programs in Windows, for example, and if one is hogging the processor time, that's going to take time away from the others if you're sharing that processor, or if you're running multiple websites on the same web server. If your website hogs the processor, that's going to slow down other people's websites. As you can see, it's still going. So this is considerably slower. And one of the things that I wondered whether when machine learning became used a lot more for things like personal assistants, Siri and Google Assistant, etc., is whether there'd been a big breakthrough in the way that machine learning worked. But actually, I think one of the big reasons that it's usable now and it wasn't when I was a student is just how much faster the computers are. So that took a minute to run pretty much. Whereas it was pretty much instantaneous. So you can sort of see why the teachers that I encountered in that forum weren't particularly bothered about efficiency when I suggested that using nested loops wasn't an efficient solution. However, you can see, if I change this, so if we go back to the problem, what do we know? Well, we know because the total was 285 and the cost was like between £1 and £2 for each cup, we can see that there's going to be quite a lot of cups sold. So we can see that actually if we start high and work down, that might be a quicker way of finding the solution. But also is that nested loop, isn't it? That nested loops, you're going to get kind of n squared on your big O there. So could we do it with one loop? Well, one thing we could do is we could do this. So we could say, we could start off, let's assume, we'll start high. We'll assume that you sell 100 cups. And what we're going to do is, while we haven't found a solution, we do know, I'm cheating slightly here because we know there's only one solution. But so while we haven't found a solution, we'll keep looking for one. And so to get that to work, we need a Boolean variable. So solution equals false. So that represents whether we found a solution or not. So one thing we'll often forget when we're doing a while loop is to increment our counter, isn't it? So I'm going to just put that in before I forget. So I'm going to add one. No, I'm not. I'm going to take one off because we're going down. And what I'm going to do is I'm going to, like we did in the basic version, I'm going to use an integer value, because what I'm going to do is I'm going to assume that I sell 100 cups of tea, or sell cups of tea. So if I spend my money on the tea, how much money is left out of the £285? So it's going to be £285, but I'm scaling all the numbers up by a factor of 10 so that I don't need to use floats. So I'm going to use 2,850, and I'm going to take off tea, which is the number of cups of tea that I've sold, times 12, which is our £1.20 in kind of 10p units. So that means if I sell the first time round 100 cups of tea, that's going to be £120. There's going to be £165 left. What I can then check is £165 a multiple of £1.90? Or in this case, is it, because it's 10 times bigger, is it going to be a multiple of 19? So what I'm going to check is if the balance mod 19 equals 0, then what am I going to do? Well, we'll say we found a solution. So solution equals true. So we'll stop that loop. And then what I'm going to do at the end is I'm going to print, what we're going to print. We'll print the number of cups of tea to begin with. So print tea. So if I run that, we'll see it says 94. Now, that was slightly quicker, wasn't it? Why is it saying 94 when we know the answer is 95? Well, it's saying 94 because it's decrementing the counter after we've done the calculation. So actually, we could say t plus 1 in here, or we could add one back on. But actually, what we could do is we could just start off at 101 and do this at the top of the loop. So do that as the first thing, and then that should give us the right answer. Okay, so that's 95. And then what we need to work out is how many cups of coffee there were. Well, the cup of coffee, so C, is going to be the balance, so the remainder of the money after we've subtracted the cost of the tea, divided by 19, which is the cost in 10p units of the coffee. So if I run that now, I can print both numbers. I can print the T and C, and I get 95 and 90, same answer as I did with the first version of the program. How many repetitions does this require? Well, we could count them up. You could probably work it out. But if I say reps equals 0 and reps plus equals 1, and then at the end, just zoom out slightly. There we go. Print repetitions. Repetitions. Okay, if I run that now, we can see actually, yep, it's right. Reps doesn't exist, so let's try that again. There we go. And that's done 6 loops. So 6 loops compared with 10,000 in the first version. Not a huge amount of difference in Python, but let's see what happens when we have a look at our BBC Micros. This is a BBC Micro emulator running at kind of 1980s speed. So what I'm going to do is I'm going to load the other version, which I can see is called Repeat. Now the other interesting thing you hear is BBC Basic hasn't got a while, it's got a repeat. So I had to kind of flip the logic. So I did it slightly differently. So if I just load repeat, and if you're doing OCR, GCSE, the repeat until is in the specification, isn't it? Even though it's not available in Python. So it's worth it. You could have a look at this. Obviously, you can use the ERL interpreter, which is available online, but you won't get the slowness that you'll get with using this. So that's basically the same program. All I've done there, line 10 resets the counter, the timer, and then it prints the time at the end. But basically, it's the same. Mod is the mod operator, as that is in ERL. Div is the integer division operator. But we've got repeat until. So rather than doing it while the solution was false, we're doing it until solution is 1. So I've also used 1 and 0 integers instead of true and false. So if you run that, let's see how long that takes. So bearing in mind it took a minute, the first version. Well, it's so quick, actually, that is like in spreadsheets, that's standard form answer. So that's 9 times 10 to the power minus 2 seconds that it took. So it's found the answer, but it's done it in, what's that, 0.09 seconds compared with a minute. So that idea of efficiency being something that will be forgotten about when computers are much faster, well, I think this is a good example, isn't it? Because we didn't notice there being much difference in the Python version, but this is, well, it's thousands of times faster, isn't it?